Section 2.1, we're going to be solving equations using the intersection and x-intercept methods. Before we get started, let's just talk about some different names for solutions. Those include the zeroes, the x-intercepts, and the roots of equations. So you'll hear me use all of those interchangeably, but they all mean that we're finding the solutions of an equation. Let's look at this equation we have here, x squared plus 2x minus 8. And we can solve this equation using the intersection method or by using the x-intercept method. It doesn't really matter. Either one is fine. So if you're looking at this, and let's say it's a parabola, so let's say it looks something like this. The x-intercepts are here. Those are also the solutions because it's where y is going to be equal to 0. Okay, so for this one, a solution is going to be a number that when it's substituted for the variable, it's going to produce a true statement. So right here we have an absolute value expression set equal to a cubic polynomial, and what we're trying to do is find the solutions. Now, in this case, what you probably want to do is find the intersection method because you have two separate functions going on here. One function on this side and another on this side. So when you have two of them, then either you can get everything on one side, set it equal to 0, and find the solutions or the x-intercepts. But in this case, what we want to do is find the intersection of the two. And in this section, we are going to primarily be using our calculators. We'll do this algebraically a little bit later. So we are going to pull up our calculators, and I'm going to show you how to put this equation in here, and then let's see if I can go double screen. I'm going to show you how to put this in to your calculator, and then a little later I will already have the equations in. So the first thing we need to do is bring up the absolute value here in y1. So I'm going to my math key, which is here. Hit the right arrow, go over to number, press enter on absolute value. And you do need to be trying this with me and as well as sketching a graph on each one of these. So we're looking for the absolute value of x squared minus 3x minus 5. Okay, so we get that. We're going to put that in as our first equation. Notice how I labeled it equation 1. Now for equation 2, I'm putting in my x cubed minus x minus 2. Okay, so I have the first side of this equation here is my y1, and we're trying to find out when that's equal to y2. We're going to find out where those intersect, and that should give me my solutions, which are the x values. So we're going to go ahead and look at a graph of this. Do zoom 6, which takes you to your standard viewing window. And we can see now where they intersect. It looks like they intersect at one point here. Of course, you can expand your graph to make sure that's what's happening. It looks like it's going a little further down than what it needs to, so I'm just going to go ahead and change this so that my y minimum is only something like -2. Maybe let's go up a little further, though, and make this 15 so we can see what's going on. So it looks like we see the intersection of the two graphs. So I'm going to now go ahead and try to find that intersection. So I'll press my second key and then my trace key, or second, and then in blue up above it, it says calc. I'm going to find the intersection, which is number 5. Press enter on number 5. And then it's asking, is it on one of the two curves? Okay, yes, it is. It's on one of them. So I'm going to press enter. And now it's asking is it on the second one? And it is. It's sort of down at the bottom. You can see it. But if you want to move your arrow a little bit, you can. Press enter. And now the next thing it's going to ask me is, do you want me to guess what this intersection is? And yes, we do. And it tells us that our intersection is at approximately x equals 2.22. We don't need to worry about the y in this example. So we have a graph, and let's come over here and make sure we get a graph. So here's our graph here. And we know our solution is about right here, and the solution to that is where x is approximately 2.22. And for these, let's round to the hundredths value. Okay, so one solution in this case. Okay, let's move on to our next example. And in this one, we are solving the equation y equals x to the fourth minus 2x squared minus 3x minus 2. Now, in this case, we want to solve it, so we can just change that y to 0. Okay, so whereas last time we had two different equations, two different polynomial equations, this time we have a polynomial equation set equal to 0. So all we're going to do in this case is just use the x-intercept method, which means that we want to graph this and find out where it hits the x-axis. So let's use our calculator to do that. Go ahead and put that equation into your calculator. You can clear out the other two. I'm simply going to turn mine off just by pressing enter on the equals, and then turn this one back on because I already have it in. And I'm going to graph that. When I graph it, I'm still in the other window, so I'm going to do a zoom 6 to go back to my standard viewing window. And you can see that we do have two x-intercepts. So what that means is, whereas the last one had one solution, this one looks like it has two solutions. Let's zoom in on that by getting rid of some of that x-axis we don't need. Right now the x-minimum is at -10. Let's change that to -5, and let's change the max to 5. Let's graph. Okay, now I'm going to snap a little picture of this so I can talk about something really quick. Okay, so what we have here, now that we have this, this here, you can see that the solutions are going to be here and here. Now, when you ask your calculator to find these, what we're going to do is we're going to go to second, calc again, but this time we are finding the zeros, which is number 2. So press enter. Now it's asking you for a left boundary. Okay, so let's go back over here and talk for a second. So let's say we're trying to find this one first. Okay, it happens right there at the green point. We want a left boundary. Okay, to the left of this red line here that goes through that point, to the left is somewhere on this, in this blue area. So we need to make it click to the left of it, somewhere over there. Then when it asks for our right boundary, then that's going to be somewhere over here. So we want to make it do a little click to the right side of it. So we're trapping it, doing a left side and a right side. This would be the left, this would be the right. And then when you go to do the other point, you've got to make it go down here. This is going to be the left, and somewhere up here is going to be to the right, and your calculator will then find, estimate what that 0 is for you. So, okay, it's asking to the left of it, so let's go over here. Let's find the one on the left first. Okay, to the left of that point is somewhere about right there, so press enter. Now it's asking me for a right boundary, so I come back to the other side of it, and I press enter, and then it's saying, do you want me to guess? Yes, we want to guess. And it looks like that solution is at -1. All right, and now, so we've got one solution where x equals -1. So here, one solution is x equals -1, and that's this one. And now we're finding the second solution at x equals, second calc. I'm going to number 2 because I'm finding the 0. And I've got to use my arrows to get a little bit closer to the 0 that I'm trying to find now. Okay, that's good. So I'm going to press enter. Now that's the left boundary. Now I'm looking for a right boundary. That looks good. Press enter. Yes, I wanted to guess. And it looks like this solution is where x equals 2. So here we're good. We have two solutions in this case, x equals -1 and x equals 2. All right, so for this problem, again, we have an absolute value set equal to another polynomial. So we know that we are going to not use the x-intercept method. We're going to use this is y1, this is y2. We're going to enter two equations, and we are going to use the intersection method. So we're going to graph those two and find out where they intersect. You need to put those into your calculator, and I already have them in mine. So here's the first one. I'm going to turn that on, and the second one. Okay, and you can see my graph is coming up now. All right. Now you graph the first one, and the first one graphs, the second one graphs, but it looks like we don't see the full story on the second one. So what I'm going to do is get rid of some of my x-axis, some of my y-axis, go up a little further in the y direction and see if I can find out what's going on there. Let's say I change my y minimum to -2 and my y max to something like 20. And let's graph now. So it was a little bit deceiving at first. At first it looked like on that standard viewing window that there was only one solution. But then when we look a little closer at the graph, we notice that there are actually two solutions here. So make sure you're doing this on your calculator as you go along with me, and make sure you're making a sketch of your graph to take your notes. All right, so let's make sure we understand where the two solutions are. There's one solution and there's the other. We're using the intersection method to find these. So back with our calculators, we're going second, calc, and we are finding the intersection, which is number 5, and it's on the first curve. I'm going to get a little closer to this one here on the left, just so that we make sure we are getting each one. Okay, so it's on the first curve. Press enter. Yes, it's on the second curve now. I'll press enter. And yes, I want it to guess, so I press enter again. And it tells me that that intersection is going to take place at approximately -3.4. So, one solution is this one. X equals -3.4. And now we have the second one to find. This is approximately, actually. So X is approximately. Let's find the second one. Second calc. Again, the intersection, number 5. Use my right arrow to get closer to the solution over here on the right. And if you lose your cursor, just look at your X values to find out where it might be. Okay, there we go. Pretty close. Press enter. Second curve, yes. Press enter. Now we want you to guess. And it looks like that's going to be at approximately X equals 3.87. Make sure you're rounding correctly. All right, so now we've done intersection and x-intercept methods both. Now it's just going to be a little more practice on each of those. Okay, here we go. This one, you've got a y equal to a polynomial function, so we are just going to change that y to 0, and -x to the 5th plus x cubed minus x squared plus 5. And now we want to graph that. We only have to graph one equation this time because we are going to be using the x-intercept method. There's just one equation and we want to set that equal to 0. Okay, and here's my equation. So I'm going to turn that on and graph it. I'm going to be using the and we look at our graph. Let's do a zoom 6, standard viewing window. Okay, it looks like a one solution problem here. So looking at it, then our one solution happens to be right in there. And we're going to find out what x is at that point. Second calc, I'm looking for the 0 this time, which is number 2. I'm looking for a left boundary, so I'm going to get a little bit closer to it. There. And now I'm looking for a right boundary. Again, a little closer. There we go. And yes, I want you to guess. And this 0 looks like it's at approximately 1.42. So, okay, there we go. And our next example, this time we're switching back and we have two polynomials. Now you have a couple of options here. This one doesn't involve any absolute values. It's pretty simple. You could get everything on one side, and if you did, that would look something like this. Plus 4 plus x. You could get everything on one side and use this as y1, and then from here you're going to use the x-intercept method. Or you could take it just like it is and enter that as y1, that in as y2, and then if you're doing that, then you're going to be using the intersection method. All right, so I'm going to go with the intersection method here, but that doesn't mean you have to. In fact, it might be a good idea for you to try it the other way and see if you came up with the same solution. You should come up with the same solution. All right, so we're going down. I already have this equation entered, so I just need to find it. Okay, that's the first one and the second one. Okay, graphing both of those. And it looks like you can see that they do intersect. And it looks like they intersect at only one point, but we're not getting the best graph right now. It looks like there's a whole lot of x on the negative side, x on the positive side that we don't need. So let's change our window so that our x minimum is something like -4 and +4. So it looks pretty symmetric. And we could have even taken more off. Okay, so now we get a better idea of where that intersection is. And so now I'm going second, calc, and I'm looking for number 5, which is the intersection. It's asking if it's on the first curve. I'm just going to get a little closer to that intersection and say yes, there. Now the second curve, press enter, and yes, we do want to guess. And it looks like that intersection is at approximately -1.28. So, and there we have that one solution for that problem. Okay, a couple more problems here, a little more practice. Now these are just a little bit different. The one here I have square root. Okay, so I have a radical equation. Now with the radical equation, it's set equal to 0. So most likely here, I'm just going to go ahead and use the 0, or I guess I should say the x-intercept method. That's what I've been calling it. All right, so you're going to use this x-intercept method. Now, the thing you need to understand about your radical is that whatever's in here, if there is a 0 in here, we have to have a 0 in there in order to get the square root of 0, 0. That's the only thing that's going to produce a 0. So what that means is that whatever is in here has got to be 0. So we can take a shortcut. That means that we can get rid of the square root part and just say that what we know is that x to the 4th minus 3x cubed plus 2x squared minus 1 has got to be equal to 0. Put this in as our y, and we're going to find out what the x-intercepts are for that. Okay. Okay, here it is. And I'm going to graph it. And there it looks like I have two x-intercepts. So I'm going to find both of those. Second, calc. I'm looking for number 2, which is a 0. To the left of the one on the left is going to be here. Press enter. Now I can move to the right side of that. Press enter, and I am looking to guess. And it looks like that first 0 is at approximately negative 0.51. Okay. Okay, now let's move back and find the other one. Second, calc. Number 2. And got to move a little closer to it. Okay, press enter. Now let's move to the right side of it. And it looks like this 0 is at approximately x equals 2.18. Okay, and there we have our two solutions for that one. And now our last problem. Here we have a fractional equation, and to deal with fractional equations, we're looking for when is this fractional equation equal to 0. Well, what you should know is that 0 over any number is equal to 0, except for, you can't have that bottom number, you can't have a 0 in the denominator. So what that means is that this 2x squared minus x minus 3 has got to be equal to 0. So we can take a shortcut, once again, like we did last time, and not deal with the denominator of that fraction. And here's our equation. We're going to graph this one. And it looks pretty clear. It looks like we have some nice x-intercepts at this one. Maybe some ones where we're not going to be approximating, but actually finding the exact value. So we're going to do second, calc. We are finding the 0, which is number 2. The left boundary in this case. And now the right boundary. And it looks like one of the zeros is happening where x is approximately, or actually not approximately, but exactly at negative 1. And then it looks like the second one is happening. Let's find out what it might be. And we wanted to guess, and this one at 1.5. Okay. So 2 solutions there. And that's all I have for section 2.1. We will pick back up with section 2.3 a little later.